quick. So hi everyone, my name is James, and I lead a lot of the work on our community and partnerships here at 12 Labs. And welcome to Multimodal Weekly webinar series hosted by our company. We've been meeting on a weekly basis every Friday, and here's some of the topics that we tend to cover. News research in multimodal AI and foundation models, innovative application of multimodal in different verticals. We have community members who view interesting video and multimodal projects that they tend to share. And sometimes we have internal talks from our team members giving tutorials and guides on using our platforms and API. In some of the recent sessions, we have, as you can see here, a wide ranging of topics, ranging from people working in video editing to researchers who are working in like vision language model, the Gen AI piloting video agent, to startup that building enterprise data database to support multimodal AI. So for this session today, we'd love to welcome the team from Surgical Data Science Collective, who is one of our users and partners of 12 Labs. The title of the talk is Next Generation Surgical Insights, Exploring SDSC's Platform and Visual Enhancement with 12 Labs AI. So the structure of the webinar will be broken down into two parts. In the first part, we'll have Dr. Donoho, the founder of SDSC, give a high-level overview of the organization, the platform that you offer, and some of the interesting use cases that you have. In the second part of the webinar, we have Margaux Masson-Forsythe, Director of Machine Learning at SDSC, who will go over, I guess, the demo that you show using our tools within SDSC platform, and perhaps also paint a vision of what surgical AI can look like with the rise of multimodal AI. Yeah, so with that, just one quick note on the logistics. So for live audience, feel free to send your question on Zoom chat, and we also have I guess a Q&A session after both speakers finish for this one. So with that, I will stop sharing my screen, and I'll let Daniel, if you want to share your screen and get started with your presentation.
All right, let me go ahead and
Too many tabs.
Too many tabs, too many usual problems. So yeah, no, it's a pleasure to be here with the team at 12 Labs. My name is Daniel Donoho. I'm a pediatric neurosurgeon and founder of the Surgical Data Science Collective. We'll explain in this first portion of the talk who we are and what we do, and why we're interested in finding collaborators in this space who are interested in working with complex visual data, particularly video, to help improve the quality of surgical care worldwide. So SDSC, or the Surgical Data Science Collective, is a nonprofit medical research organization. Our mission is to serve as the hub of surgical data worldwide, with a particular attention to surgical video. We create a community that advances digital surgery, and we work on standards and processes for better sharing and storing of surgical video. We facilitate the exchange of surgical knowledge and expertise worldwide through a video platform, and that's what I'm going to show you today. So by the end of this talk, you'll understand who we are and what we do, and you'll have seen at least a little bit of a glimpse of what our current public-facing version of the platform is. I think a lot of the interesting insights will be shared by Margaux, who's our Director of Machine Learning, who will explain both some of the things that we're doing behind the hood right now, as well as some of our more forward-thinking aims, particularly with the concept of video understanding. So why do we need another medical research organization? And why do we need to attack this problem of global surgery? Aren't surgeons good enough and smart enough already? Well, the principal challenge that surgeons face every day is the ability to share knowledge. Surgeons are often lone wolves. They operate by themselves or sometimes in small packs. And when one surgeon comes up with an innovative technique, it often takes many years or decades for that innovation to diffuse throughout the entire world. One of the reasons why this happens is that most surgical training is actually done in person, Just like in the pre-pandemic era, we did everything in person. This makes it inaccessible to many. Just think about how many people could watch this webinar versus how many people can come to my office in my hospital to understand what I do on a daily basis. One of the primary inequities of this mode of knowledge transfer is that it disadvantages folks in other locations or other countries from where the innovation is principally occurring. This has detrimental effects actually throughout the world, but in one of the places where we have the greatest need for surgery, it is particularly harmful. Low and middle income countries particularly suffer from a lack of trained surgical specialists and a greater difficulty in having knowledge diffused to them and also from them in this current paradigm. And this bidirectional idea, the concept that innovation could happen anywhere on earth, whatever the income status of the country, but that in some areas that innovation will never diffuse out and that knowledge will never be transferred, is what we aim to attack. The reason we believe this is feasible is that many surgical procedures are actually captured by video cameras. In this case, we're not interested in the video cameras that are in the overhead light or in the wall, but we're talking about video cameras that surgeons actually use to perform the procedures. The surgeon is watching a screen, the camera is placed inside the body, and the surgeon places instruments and performs surgical tasks based on the view that they obtain on the monitor. This means that the entire surgical episode can be captured on video. Since we're capturing millions of hours of surgical video every year, humans can't possibly watch all of that. And as a result, most surgical video information goes unanalyzed. We believe that there's a critical opportunity now to use advances in artificial intelligence, computer vision, machine learning to understand these data at scale, global scale. And this can facilitate both remote training and knowledge transfer if we're willing to allocate resources. A little bit about who we are and what we do. We mentioned that we're a nonprofit. So a common question I get is, why don't you just start a venture-backed startup, Dan? And I think that's a reasonable path, but I think we also have a sense of where that might go. The current ecosystem doesn't harness the kind of data that we're most interested in for patient care and for improving surgery and for diffusing knowledge, because there's a lack of return on investment in the immediate 8, 12, 24-month period for creating systems that can process and understand that video. Even if in the longer run or in a non-market directed context, understanding that video might be critical to human health. But if it doesn't make a greater marginal dollar than the next idea, that data remains unharnessed. As a result, in the market, a lot of AI is being channeled towards hospital operations and administrative functions, just as it is in conventional businesses. This does maximize profits, but it does not improve global impact. Lastly, when we do see AI currently being deployed in the operating room today, it often comes inside large and expensive hardware systems. That's because that's how you can easily monetize a software element. There's a massive surgical robotics market, and I love robots too, but that's a difficult problem when all of the great software ideas are bundled with that extremely expensive hardware. This makes most surgical AI inaccessible to hospitals throughout the world and really limits the diffusion of knowledge and the rate of training new surgeons. So what do? We are the Surgical Data Science Collective, as we mentioned. We're a nonprofit organization, and this puts some guardrails on what we can do. We're focused on impact and on improving the skill and performance of surgical practitioners and the understanding of surgery as a science. As a result, we connect these clinicians and data and scientists. We maintain a secure data repository. We are optimized to analyze surgical video, which is an unusual data type within medical study of medical data. And we provide a clinician-facing as well as a research-facing platform, and we're supported by private philanthropy. So why does such an organization need to exist, and what functions can it perform for the people who are listening to this call? Well, believe it or not, on the left side of the screen, we have surgeons who may have a lot of data in their hospital. They may want AI tools for clinical impact. They may even know the local and even the global context for where these tools could be implemented, but they don't have the technical domain knowledge to actually do the thing. On the other hand, there's a really robust area of computer science research and applications of computer vision and machine learning to medical data. Unfortunately, researchers are often stymied in this field because they don't have access to the data, and they rely on these complex webs of social relationships to gain access to underlying data. And when they get it, it's only on a project-by-project basis. There are also very limited deployment capabilities for researchers. How can they actually put a tool in front of clinicians so that clinicians can use it? There's a very lengthy process that involves both regulatory, but more importantly, sort of a cultural social exchange that is often not performed. As a result, most innovations in this space become great research papers and top presentations at conferences, but that's all. They don't go farther. The researchers, obviously, as we mentioned, have excellent understanding of the computational state of the art, but they don't have the context of the medical domain, and they rely on generalizations that often mean that their insights don't capture what practitioners need. And lastly, as we said, these insights are not designed for productization. So our aim is to put these two puzzle pieces together in a compelling package that's available to anywhere on Earth that serves some functions for researchers, probably the primary audience of this call, and some functions for clinicians as well. What does this look like in practice? We operate a surgical video platform, which is a web service that's available. Surgeons can log in, upload videos, organize their procedures. They can automatically receive inference results against their videos, which provides researchers with a very potent way to have impact on the surgical domain itself, as well as to deploy models that can gain greater validation and understanding through the exposure to a wider variety of surgical data in the wild, rather than just the very most carefully curated data sets. This, as Margaux will probably to her chagrin tell you, can often result in exposing models' underperformance in a very important, unique way, but one that's critical to understand how these models can have impact. We also allow some functions that are related to collaboration and surgeon interaction that we feel are important to building community and sharing ideas worldwide. Of course, this is all cloud-based. This allows surgeons to access their videos from anywhere on Earth and to share them with any colleague anywhere on Earth. And this is critical, again, to diffusing knowledge. As you can see in this video, that represents the web platform. You upload your files, and then you go through some standard steps to share those with your colleagues. It sounds trivial, but it's crazy, and it's crazy to say, but nothing like this actually exists for practicing surgeons in a private and protected environment. You can post your videos to YouTube or to a Facebook group, but you actually can't do this thing that we've enabled. Once we have models that are actually running on our site, surgeons can use these models to receive instant feedback on their procedures. It might be surprising to tell you, but most surgeons never receive any feedback on their surgeries themselves. Maybe you have a trusted colleague who watches part of your procedure. Maybe you have a mentor who's willing to look at a small snippet of video, but it's actually quite difficult to receive feedback on what you are doing in the operating room. And of course, measured against this, surgeons receive very potent feedback on their results, but no feedback on their processes. We solve that by providing these deployments on any video that's uploaded to our platform of the appropriate procedure type for the model. This allows surgeons to understand exactly where things went right or where things might have gone better. And we provide a very fine-grained level of analytics, including understanding exactly where instruments were and how they interacted with each other and with tissue. And these kinds of insights are going to be critical to creating a greater understanding and really a new science of surgery itself. We encourage collaboration, and this is where our partnership with 12 Labs is really exciting. We are very excited to see summarization of long videos in text with chapters and highlights automatically created. We do understand that large foundational models may fail to capture this as eloquently as fine-tuned models might, and we're very excited to see where this direction goes. Videos are a tough data type for large models, and this is something that's a continued area of research and exploration for us, and one where I want to explicitly call for your participation. And we think that we can have a really great collaborative opportunity here together. Facing the user back again, we provide high-level statistics about what procedures they've performed, basic metrics about time, and various other functions across procedures that allow surgeons to track their progress longitudinally. A common question I get from surgeons is, am I getting better? And we believe that these kinds of analytics will allow us to, for the first time, be able to answer that question and to do so at scale. Lastly, surgeons are some of the most time-starved people on Earth. So being able to get them to the parts of the video that they want to watch in a fairly automated fashion delivers great value to our users. So by automatically grouping procedures into phases and steps, which are technical terms that refer to both the mid-level sort of operational goal of the surgery, as well as the fine-grained individual actions that surgeons are taking that achieve a measurable goal. This way, surgeons don't have to figure out, oh, was it at 1 hour and 10 minutes that I did that thing? They can click and they're immediately taken to the relevant portion of the video. We believe that this platform is extremely useful for our surgeons, both from a research standpoint, so that clinicians can understand how their surgeries are actually being performed and can understand relevant differences between them. For education, transferring again in this bidirectional fashion across the world, the best of surgical knowledge, and for allowing surgeons to gain skill and improve their performance. There are a host of models that we're developing, some of which you'll hear about from Margaux. And we're expanding into other domains. We also have some very interesting partnerships with other non-governmental organizations and nonprofits, as well as major hospital systems, to deliver this kind of technology at scale for specific uses that surgeons are really asking for to make surgical care better anywhere on Earth. One example of this kind of partnership is our partnership with NeuroKids. So NeuroKids is a group of surgeons from all around the world who want to master a particular procedure to treat a disease called hydrocephalus. Hydrocephalus is a neurologic condition where babies, children, infants, and even adults accumulate too much fluid within the brain. When this happens, children and adults are at risk of life-threatening harm. There are more than 400,000 children on Earth diagnosed with hydrocephalus every year. But as you may imagine, there aren't enough neurosurgeons right now to take care of them, and they don't all have access to the kinds of resource-intensive therapies that we can perform in a high-income country. So NeuroKids has helped increase the adoption of a very resource independent procedure with very limited number of tools, and we're working on improving the surgeon performance in this innovative procedure throughout the world. There is a significant discrepancy in how effective this procedure is in different patients and in the hands of different surgeons. And our goal is to raise the bar for every single surgeon worldwide to improve their performance so that every surgeon is as performant, so to speak, as the best surgeons. We currently have surgeons all over the world who are working through SDSC, uploading many procedures and thousands of hours of video so that they can improve their performance, receive feedback from colleagues, and even just understand what it is that they're doing on a daily basis. So it's our privilege and our pleasure to partner with other like-minded organizations to improve the state of the art for surgery and to transform surgery really from an art into a science. Leave a QR code up here for a minute for anyone who wants to take a look at it. Send us an email, or you can find us at www.surgicalvideo.io. I'm going to pause the share there.
Awesome.
And
yep, thanks, Daniel. Yeah, we can just take maybe 5 minutes for any question about SDSC before we move to the second part. Yeah, so if you have any question, just please put them on the chat. Yeah, but personally, I'm curious. Like, I think one of the earlier slides you mentioned about the company building phase, where you set it up as a nonprofit and you're connecting both the researcher persona as well as the surgeon and hospital, demographics. Like, well, how did you, I guess that from the early days, how did you, let these type of folks know about SDSC, the organization, and incentivize them to, from one end contribute to research and from the other end contribute to data?
Yeah, so I'm sort of a mix of both of these. So I started doing work in surgical simulation about 10 years ago at this point. And this was right around the time that computer vision was really becoming a thing. Thanks to some massive challenges, big data sets that were available, these models were coming out that were, again, benchmarked and built in a very, sort of iterative fashion with, shared code bases and repos that, could be used to improve model performance year on year. So we started to understand that some of the videos we were capturing of surgeons could potentially, for the first time, actually be studied. So we started saving the videos. We've actually published 2 open source data sets of surgery, and those are available for anyone to use. They've been used for multiple NIH and NSF proposals. And we really want to encourage folks to start to see surgery folks in the research community to start to see surgery as a really viable place where you can train models, where you can find data, and where you could bring your latest algorithmic innovation rather than training on cat videos. You might be able to train on videos of surgery, thereby improving human health at the same time as publishing your great NeurOps paper. As far as how we incentivize people and how we do this matchmaking function, even though we have more than 100 surgeons working with us and several really impressive research groups, I think it's still early days for us. And I think one of the reasons we're coming to this community is to raise awareness about this process and to really open our doors and say, we're here, we're ready for business. If this is something that you're interested in, working with this data type or, working with 12 labs in us, we really want to encourage you to reach out to us because raising awareness on this availability of this kind of resource is actually critical in a world where everyone can find, Epic Kitchens or, other kinds of video and data sets that, in the public domain.
For sure. And in terms of the platform itself, I think you did a great job of touching on like each of these phases of what it offers, from the initial data uploading to some of the capabilities around video analytics that the platform offers. So maybe just curious about one question around the video uploading part, because I think you mentioned people can upload their surgical videos on your platform via the cloud, right? I think considering the nature of this type of video, very graphics and I would say pretty sensitive, was there any guardrails that you were thinking about putting around the type of video that can be uploaded to your platform?
Yeah, so we certainly by design handle sensitive and private information, and we do so in accordance with standards both in the US and internationally to make sure that we are in compliance with local rules and regulations. I think one of the perks of the video data type that we work with is that it's video from inside the body. So we don't have pictures of people's faces. We don't have those kinds of things. So a lot of the identification concerns are smaller, not zero, and we do have ways to reduce the risks of those kinds of privacy breaches as well. As far as guardrails and these kinds of things, I think we spend a lot of time with our partners. We work very closely with them, and we do manage access to this data. So it's not in the sense that anyone on earth can just download the petabyte scale data repository and somehow find that useful, because number one, it actually wouldn't be useful, and number two, there would be some significant concerns about that process. So we're working with our early adopters from the research community to best design exactly how this kind of model can work, where researchers have access to do the kinds of things they need to do in terms of model training and validation and even post-deployment model monitoring, while maintaining the privacy and sensitivity of this kind of medical data.
Yep, perfect. And then one final question before we move to the second part. A question from Manish in the chat here. Is there any feedback from surgeons or research group to improve their procedures? And I think this one, you do have one slide about the analytics component. So if you can, don't mind, just double click on that point real quick.
Yeah, absolutely. I'll show I'll pull that slide back up again. But for example, again, I think we have to compare ourselves against, anytime we're doing anything in ML, especially in medicine, we have to compare ourselves against the human benchmark, right? Or against what really is the standard today. So right now, surgeons outside of a training context, practicing surgeons, receive absolutely no feedback. So these kinds of analytics, to be honest, are early. But we have validated analytics in other models before, including in some of the simulation data that I did. So we believe that there's a lot of value. The second, on kind of a face validity concept, we're starting to see these kinds of analytics become increasingly prevalent in things like sports. And I think as a global community, we believe that there's a tremendous amount of information in video that can be unlocked now, and that can provide really interesting and new types of predictions and types of process improvement that we've never seen before. To be clear, it's early days for this, which is exciting. It means you have the opportunity to get in on the ground floor. It's also challenging because we are figuring out how to integrate this information into the clinical context. we don't know as surgeons how to handle some of this information because we've never had it before. We've never integrated these kinds of rational processes into surgical training. We haven't quantified surgery to the extent that we have other human endeavors. So we do have to figure out and work with clinicians and work with domain experts and work with technical experts to figure out how we actually do the human factors piece of this to improve performance. As far as the other question about researchers, I think we do give a lot of model analytics, and we have found a lot of really interesting cases and situations from this large and very diverse data set of surgical procedures that otherwise might have been difficult to find in the more canonical surgical video task data set. Some of the models that are extremely performant in those grand challenge data sets, which are amazing, and I completely encourage them, they aren't as performant once they're exposed to videos in the wild as they might have been in the challenge data set. So this kind of validation, multi-center data, global data, I think is really critical to ensure that algorithms and their ensuing predictions are robust to the kinds of variations that we see in everyday surgical practice.
Awesome. Yeah, I think that's a great answer from both angles to the question. Well, so thanks, Daniel, for your part about SDSC, the platform, and how it works. So I would love to turn it to Margaux to start sharing the screen and go over the demo portion of the webinar.
Thank you, James. So I'm going to start actually with a short demo of our platform since Dan was talking about it. Can you see my screen well?
Yep, I'm seeing your platform.
Thank you very much. Okay, so as you have heard from Dan, our platform is used for uploading surgical videos and getting automatic feedback on the video. So surgeons and other medical experts can go and create a procedure, upload their videos, and we've already seen that in the slide. So what I want to focus on here is the actual more in-depth analytics and how we can then switch and integrate to using 12 Labs API at some point in our platform. So the first example that I want to show is on a pituitary tumor surgery video, which is a surgery that is performed in the brain. So it's an endoscopic endonasal surgery for removing tumor in the brain. So here you can see on the platform that we have the video that is streaming. We can add some notes if we want about the procedure. So I can go around here, for example, and say, I'm not a surgeon, so something important is happening here. We can add comments once the videos are shared with peers and colleagues. And then we can get the tools analytics that we were mentioning in the slides. So here you can see we have different heat maps that are derived from our computer vision models. So for example, if I go back at the beginning of the video, you can see here that this tool is a suction and this tool is a curette. So we can see they are kind of at the bottom of the screen. The curette tends to go a little bit to the right side of the screen. So if I go here, I can see that I have my suction here that is most of the time on the bottom left corner of the screen. I also have my curette that tends to do some sort of arcs. These heat maps are over the whole procedure, and we're working to have them per different phases of the surgery. If I go a bit further here, I was trying to find another tool to show you guys. Okay, so we can still see we have the curate here, but by looking here on the heat map, which is a great example of how the surgeons can go and get really overview of their procedure at one glance, you can see that we also have the different tools, grasper and roton dissector, and we can see where they appear on the screen and have this view at one glance. We have other graphs where we can see the number of tool appearances. So we see that the suction is on the screen quite often. And then the units that are traveled per tool, usually the suction tends to move more than other tools. And then the tool confidence, so this is our modal confidence in the background. The other model that we have on the platform is the phases segmentation. So dividing a surgical video into several phases, which I like to call chapters as well, because it also works well with what 12 Lab is developing. So if I go with one of the procedures that was shared with me, because here you can also go and share it with your peers. But if I go to one that was shared with me, I can see this one is a different procedure called cholecystectomy. I can go into the procedure breakdown and I can see the different phases or step of the procedure. So the first step here is a callout triangle dissection, and then we have a gallbladder retraction. And you can see here on the actual video player, which is pretty useful. So you can see it at the top here, but you can also see it here and here. And if I want to really jump right away to the phase that I'm interested in, I can click here and then it brings me directly to that specific phase in the procedure. This one is pretty short. You can imagine that usually we have 1 to 2 hours of video, so it is very useful to have this feature. But now jumping to the 12 Lab platform and the playground. So here I uploaded a video of endoscopic pituitary tumor surgery. So the same as the same procedure as the one I had on our surgical video platform. And I'm gonna generate a report live. So what I want is the summary, the highlight, and the chapters, which is pretty close to what we want to do on our platform. And if you can imagine, if we can have a tool like that that would generate the chapters right away, we could use that on our platform to directly generate the chapters. So if I go here, I'm going to generate it. You can also imagine how useful this tool would be on our platform if surgeons are trying to write reports on their surgery. And so they could just go there and click, I want a report of this specific surgery. It's often something that they have to do. So it would be really useful. In that case, as you can see, I didn't put any prompting on the side because I wanted to try it raw. And I'm using the Pegasus model here. So in this video, I want to precise is a narrated video. So we'll have better results than usual surgical videos that we have on our platform. And that's something that we're working on that I will talk about a bit later. So here we can see that the summary is saying that it's a medical procedure performed by a specialist. I almost got it right. I mean, neurosurgery is correct. I'm not going to go through the whole summary, but we can see that it's understanding pretty much what is happening. It's using some terms that are specific to neurosurgery, like CSF leak, which is something that usually happens during that tends to happen in pituitary tumor surgeries, which is a highlight usually. So in the highlights, final stages of surgical procedure, advanced surgical, beginning of procedural surgical. Those are interesting. I wouldn't call them highlights, but that's where I'm going to use prompting next to have better results. And so it will show that we can already use what Pegasus capabilities are when we actually do good prompting, but the next step obviously would be to do fine-tuning on surgical videos that are narrated or organized per different procedures and phases, chapters, etc. So in this one, we can see that the chapters, which is something I care about a lot here, we can see that it's saying it doesn't make sense, but the only issue here is that it's not using the usual terms that we would be looking for. So for example, for pituitary tumor surgery, we want to have 4 different phases usually. And so what I'm going to do now is that I'm going to change this with some prompting that I prepared. So for the summary, I'm going to say that I want to create a report of this endoscopic surgical video as if you were the surgeon who performed it. Then for the highlights, I'm going to say, tell me the surgical relevant critical events that happen in the video, such as TSF leak, tumor removal, excessive bleeding, etc. And then for the chapters, I'm going to say, breaking that into the surgical, several surgical phases, such as nasal phase, sphenoid phase, setup phase, and closure phase, which are the phases we care about for pituitary tumor surgery. And I'm going to regenerate the report. I could also adjust the temperature, but you've seen here, I did not do it. Could potentially yield to better results. But this is a great way to test how we can use video foundation models like this one for surgical videos. And the next step you can think about here too is we could have very amazing search into videos. So for example, I am a medical resident and I'm trying to find very specific use of how to manipulate a certain tool. So I could go into the search bar and say, show me all the clips where the Roton curate is being used, and then it would just give me all of the sections of all of the surgical videos where this specific event is happening and the use of this tool is shown, so that I could really curate all of the content kind of in the same way as it's already done right now in 12 Lab with a lot of the sports videos, mostly is the ones I've been playing with, where you can just go and ask, show me whenever Federer is winning a match or something like that. Okay, so now the summary is using I, so as if I were the surgeon, and saying that it's performing an endoscopic surgery, focusing on the nasal cavity and sinus structures, which is correct, mostly. For this, I would have to ask them to read the whole thing and actually tell me if it's correct, but this is a good way to show that we can really change the output of the model. Not putting you in the spot here, Dan, but maybe after.
Yeah, it's pretty good. Couple things that I might change, but overall, I think as an operative note, you would just reformat it and change a few words, and it looks like you're pretty good to go.
Amazing. Let's take a look at the highlights. The highlights haven't changed much. I think this is probably something that would need fine-tuning, obviously. For the chapters, though, I like to see that now it's using the names that I gave it in the prompt, which is nasal phase, sphenoid phase, and closure phase. So usually we would have the nasal, well, always the nasal phase is first and the sphenoid, usually the setup phase is next and then the closure phase. So I think here it missed the setup phase, but mostly let's see what it does with the closure phase. So the closure phase would have a lot of, let me see, the cotton, okay. So the closure phase is when I was going to say the wound, but the opening is being sealed, if you think about it that way. So there's a lot of sealant and there's a cauterization happening. So that's where, that's what this phase usually is. The nasal phase is usually opening and preparing the structure. So here we can see that it's correct. It's happening in the nasal part of the head, the skull. So this is pretty accurate. And then of course we would have to do a lot of evaluation, but this is the first iteration in using video foundation model for surgical videos. And we're looking forward to continuing the collaboration with 12 Lab and fine-tuning a lot of fine-tuning the Pegasus model, but also the other model where we could do search and classification. So you can also imagine if we want to do classification with the Margaux model, we could classify between different procedure types. So we just give it the whole surgical video library and we say, classify all of the different surgical procedures. So we'd have the endoscopic endonasal procedure, we would have the microscopic videos somewhere else, and then we could have the spine surgeries, etc., the laparoscopic. So there's a lot of potential here with these kind of models. And I'm going to stop here to answer any questions. stop sharing.
Awesome. Yeah, thanks, Margaux, for that great demo of the tools and key learnings that you found by using our platform. And yeah, we were also super excited to work with you on the Fountain API and figure out different approach to increase the qualitative performance of the text output generated from the Pegasus model. So we have the rest of the webinar, probably more than 10 minutes for the Q&A. So yeah, for attendees, if you have any question, please just put them on the chat, and then we can answer them. Yeah, and maybe one question from my end is, looks like you got a chance to like actually use the prompt for those boxes, right? With our summarized endpoint. That is actually something that not a lot of people are aware of, but at least not people like bother trying. So what do you see could be improved with the prompt itself? I think in the past we got some requests to increase like character limit. Can you be a bit more like increase number of characters so that it can be more expressive in terms of what you want the actual summaries to express? But yeah, besides that one, what are some other things that you think could be desirable for this feature?
So I agree with that. With the number of characters, it would be nice to be able to write longer prompts. I think so far when I've played with the prompt boxes, it has listened pretty well to what I'm writing in the prompts. But as you can see in this demo, the highlights were slightly ignored. So maybe being able to put more emphasis into each box somehow. I'm trying to think. I was thinking that maybe having different outputs, so not only summary, highlights, and chapters would be something interesting to have as well. So in the yeah, maybe I'm asking for a lot here, but in a surgical video, you could ask for a list of all of the tools, for example. And so maybe a free form output box or something like that would be very helpful for specialized applications.
Yeah, I see. Did you got a chance to play around with the open-ended text option? And yeah, if you got a chance to play with that, and what was your, I guess, perception of the quality of the text output?
Sorry, are you asking on the playground of 12 Lab or somewhere else?
Yeah, on the playground of 12 Labs.
On the playground, I've only used the summary, highlight, and chapters. I haven't tried to actually focus the prompting on anything else yet. So.
Oh, I see. So if you don't mind, just sharing your screen once more, so I can maybe you can just try it now. I don't know. Be curious to see the performance. So next to the templates, you see the Build My Own tab.
Oh, look at that. Okay, my bad.
So this is open-ended text. So maybe you can do something with this and come up with your own prompt, and let's see how it does.
I'm trying to be a little right. I'm gonna try to put at 0.8 and see what it does.
So this is basically the open-ended option that allows our users to be more flexible with the type of output that they can get.
My feature request is already integrated. I just did not see that was focused on the highlight, summary, and chapters actually. So this is nice, and that gives me a lot of idea of all of the different things we could do next. We could also do anatomical structures, for example, if it's able to recognize them or see them.
Yep. And please verify if these are correct if you take a look at the output.
Can I tell you something crazy?
Yes.
we have no way of knowing if this is correct because we never get this kind of information in surgery. You know, at a face level, it looks good. All of the statements are logical. They seem to be, you know, generally consistent with the domain and consistent with, you know, what would be in the video. But there's so much of this that we don't know and we've never had access to in surgery. So I really commend you guys for these kinds of interfaces. And it all, yeah, you know, it works. Hey, Margaux, can you tell it to write an operative note?
Here?
Yeah. Yeah, just ask it to write an operative note for the procedure.
Operative.
Yep. Just so you know, this is a feature that surgeons commonly think they're asking for from us is like, can you write my operative notes for me at the end of the procedure so I don't have to do anything? We have to write these notes for billing and for dictation, for billing and for administrative purposes. They're, you know, it might take me 5 minutes, it might take me 15 minutes for a longer case. If I actually have to sit and type it, they're actually quite lengthy. And they have to be quite accurate. So this is a very difficult test. All right, it got something about formatting. It's maybe not exactly how I would format it, but it's pretty reasonable. I bet you could take this and put it into, you know, GPT-4 and it would reformat this again through one more step into something that would be passable. But as a content, you know, sort of an extractor, this is something that's, you know, obviously far beyond what you can do in the conventionally available, even multimodal models, because they don't have the ability to really understand video, and certainly video of this size. So I would definitely give this, you know, 4 out of 5 stars, and you know, might not be quite ready for the medical record yet, but it's pretty darn close. And with one more chain and LLM, I bet you could do it.
Yeah, I just want to notice, like, you know, like this business model, we are continuously like do a lot of research in-house to update the model weights and collect better training data. And I think one of the goals for us for the next few quarters is do more instruction tuning for the model, meaning that it can follow instruction better. And so, yeah, we hope to have that capabilities down the next update, and soon we'll be able to also do video question answering, meaning that you can chat multi-turn conversation with the model to have like a thread of conversation instead of just like a single turn, you know, output as you've seen here. So, yeah, I hope like with those upcoming updates that could be able to like give it for 5 out of 5 instead of 4.
Yeah, no, it's extremely exciting, and you know, in my heart, it's 5 out of 5. But I have to be a harsh judge to keep our standards in surgery high. So
great, awesome. Any other question from the audience before we conclude? Let's see. The Drew asked question, are we using some models like Lava for the summarization? Can we ask this question? This is more like a 12-up question. Yeah. So I think Lava is definitely like an inspiration for us. We had the similar, I like from a principle point of view, like similar approach. So Lava did a good job of like visual question answering for image-based, right? They did a great job of instruction tuning. And so like for us, we build video language modeling, right? And so basically extending Lava but to video. And I think I just answered to Daniel about the future capabilities of video question answering. So it will be able to answer question once you type it in. Yeah, so I hope that answers your question. Awesome. So yeah, I think we can conclude our webinar. Thanks, Daniel and Margaux for joining us today and spend some time preparing the materials. there as well as the demo for our audience. The recording of the session will probably be available on YouTube within the next 2-3 weeks, and I'll be sure to notify you guys when it's available, so you can share it across different channels. And yeah, hopefully to raise more awareness around SDSC and attract more researchers and surgeons to provide content for your platform.
Thank you, James.
Thanks, guys. Enjoy it and have a great rest of your weekend.
Bye, everyone.
Bye-bye.